customers. And it's something that a lot of people are talking about, and we hear these terms kind of bandied around like smart buildings and Internet of Things, and some of us might be clear about what that actually means in practice, and how we can use these things to manage risk and to manage our buildings, but some of us might not be. So that is kind of what does this actually mean in practical terms, and what are the opportunities and what are the challenges? So we thought it was important to organise this session to really go through that and hear from our subject matter experts in a bit more detail about some of the practical challenges, but also the opportunities and how can we use these things to our benefit. And we probably know that there is an opportunity, but it's about that practical challenge of, well, how do we make practical use of the devices that we can either use or the data that they give us access to? And to help us understand all of that, we've got 3 subject matter experts that we'll be hearing from today. The first person you're going to hear from is Louise Kerrigan, and Louise is the head of our property and energy practice within Zurich Resilience Solutions. And Louise is responsible for our risk engineers that are out working on site with customers, trying to help them and us understand their risk profile. And she's going to give us an overview of the big picture and some of the context for property owners with regards to things like Internet of Things and using devices, and some of that, and also some of the practical steps of how we can implement solutions in this area. The second person you'll hear from is Pete Tuckett, and Pete works for one of Zurich's strategic suppliers, GWT Insight. And Pete's got over 25 years of experience of building system performance, and he works with us to install devices that help organisations kind of make use of their data and collect the data that buildings generate. And Pete's going to talk about some of that practical experience, as also some of the key trends that we're seeing in terms of how people are using devices and data to manage property risk. And finally, last but not least, Gordon Matchett. Gordon is one of our senior risk engineers within ZRS, and Gordon works closely with our customers to implement some of the technology and solutions that we're going to talk about. So again, some of that real practical experience and what other customers are asking when they're thinking about implementing some of these solutions. So without further delay, I'll hand over to Louise.
Excellent, thanks, Alan. So before we have it, exactly as Alan said, before we kind of move on to smart buildings, we'll just take a minute to just explore IoT and what IoT actually is. So basically, it's physical objects or things that exchange information to each other or other devices or even systems over the internet. And it really is as simple as that. So we're surrounded by them, probably without even realising. Smartwatches, I've got my wearable on, our home heating systems, any kind of connected appliances we have, and absolutely good old Alexa. So no home seems to be complete now if you can't say, Alexa, turn on my TV. So they do completely surround us and are becoming more and more common in our day-to-day lives. So we've got a quick question to get in the chat to start us off. How many of these physical things do you think there are worldwide? So just guess, put your answers in the chat. Just how many of these kind of IoT devices do you think we actually have around the world? Oh my God, is it? Was it on the screen there for the people who noticed? For the ones who were watching the screen, they would have seen the answer. Yes, so I think people saw the answer. So yeah, 20.4 billion, well done. Quite a few of you got that spot on, I wonder how. But yeah, absolutely, 20.4 billion. But their expectation is, I mean, no one knows exactly, but the expectation is that this will increase to 30.9 billion by 2025, which is pretty scary, really, when we think about how much we're going to be surrounded by all of these devices. But they can be a good thing. So flood sensors can increase alert times by several hours or even days, which can enable a BCP to be implemented and therefore reduce flood damage. Earthquake sensors provide more time for people to move to a place of safety. Manufacturers can utilise the data from sensors and devices to assess current conditions, maintenance requirements, and enabling them to introduce proactive maintenance schedules. Cargo owners are able to monitor the conditions on high value climate sensitive goods, and reductions in cost of tracking devices now make it far more feasible to secure high value shipments, i.e. electronic devices that are attractive to cargo thieves. You've also got benefits for for property owners. So okay, yeah, there was a bit of a so there's also a benefit for property owners. So rents for clients and tenants are increasingly prioritising sustainable and healthy buildings over prime locations and views, and there's an increase in both sales and rents of green buildings. So rents for green buildings and sales for green buildings are both increasing, rents by 6% and sales by 7.6%. So there is a huge amount of opportunity and benefit for our customers in this space if customers can understand how they can harness this technology for their organisation.
Thank you, Louise. Just some information about buildings and building stock. A new building going on online, let's say it's completed, this year. It's probably taken 5 years to bring to completion. So if you consider all the rules, regulations, and design criteria of the building, it probably hasn't changed in 5 years. There may be some updates, but generally, once a building is in design and a build, it rarely changes unless there's something major to change on it. So even a new building looked at today with internet things connections will actually be out of date. So you're looking at the regs, the rules that are trying to run that building, and there's going to be a gap between the design and its operational performance, almost certainly. And very rarely does once the building's signed off, does the operational performance be checked and be sort of considered as how it's running, unless one, the building is using more energy than expected, or there's a performance issue within certain areas. And usually any changes aren't tracked. So looking at sensors within a building, understanding the building, collecting data from the building is going to allow you to actually tighten up the control of a building. No difference to a modern motor car, and where they use a lot more information into the vehicle to make sure it's working. A building's no different. So this in itself is going to allow you to drive a building, how it runs, and bring it and actually move the building and its ability to perform to a specification, improve it, and then bring it up to date. And that's a consideration that has to be taken in the current climate where energy prices are going up. You want to improve the building. So looking at how this data can be collected, brought in, and made use of is key. And buildings over time, use changes, but the design of the building doesn't change. And rarely does the internal side of the control of a building, or even the airflow, the air quality of the building, be adjusted other than for that requirement. So you may have a small area of a building change, but it actually could affect the whole building in its where it's changed. So the use of IoT and IoT as a support to this is becoming more of a standard. And I think it's becoming an aid within the way the building is run. So I mean, a question really as I think of, over the last 10 years, how many smart buildings would you say percentage have actually been built? And this is a poll. Interesting results coming through. So if we consider a smart building, I think there's something that's a bit of information that's understood as a building with a certain amount of intelligence. Actually, the definition of a smart building is one or more mechanical or electrical systems linked together, controlled by a central point, carrying out an automated function. So over the last 10 years, there's probably 10% of the pool are correct. Probably majority of the buildings, 80 to 100 buildings, 100% of the buildings have been built to that specification. Virtually any commercial building now will have some sort of automation. The key to collecting the data is actually linking the automation and making sure that you can actually define the way the processes are talking to each other and standardize the data that comes out of the building. So for example, you have heating, ventilation, air conditioning be under one central controller. Normally it's run by the FM guys, and they will make sure the building's performing to comfort levels and performance levels that they expect of it. But the same as in the same building, you'll have fire protection, lighting control, access control. Now, fire protection itself, there's a lot of information going around a fire system. So a sensor up in the ceiling, it's not only looking for smoke and particulate, it's also looking for temperature, it's looking for light levels as a particulate sensor. It can be looking for CO2 as a requirement as it's sensing. So all of these things can be picked up and considered as part of coming to the building. Same with lift controls and bits and pieces, and same intruder, access control. They can all be used to understand how a building's being used, to see which areas are being used within a building and how the heating and how that area is performing. So as a general rule of thumb, there's a lot of data, but the key is to be able to bring that together in a normal standardized format. So this, the ability of a building to be smart is actually considerably harder than people think, and the key to that is to select the areas you need to improve the data. So putting IoT in and putting a lot of IoT solutions in, and there's a lot of companies out there recommending IoT solutions, but it's very much it's a solution to deal with something that they've seen as an area in the market, and you actually need to bring these together and really identify where you want to make the savings and what's the best equipment to give you that sort of really the minimum amount of input to give you the maximum amount of data. It's very easy to flood a building with data, but then you've got to spend your time sorting through it and from multiple systems to see if you can actually align all the information. So examples of sensing an IoT you can look at is with you can have temporary or a permanent sensor. So for in an area where you may have hot works, you may want to put a temporary sensor into that space just for a few days while that work's been carried out, and that can be fed back into a central system. The sensors can be active or passive, so something that's physically checking movement, or a simple sensor that's just checking a door, or where someone is in a door space, or looking at the air quality. Again, these sensors can be wired or wireless, depending on the structure of the building, how it works, and what's required for the area, or even the best solution available. But again, the key is to getting the data from all these different devices into one place. And to give you some idea of the data, and the complexity when you're talking about sort of 20 million different devices coming in, and on a building itself will have, an average office building will have somewhere around 30 to 40,000 data points just on a building management system alone, which can be collected, used, and just read without actually having to be affecting the building. So if you align that with lighting control information and also the fire alarms and within the building, all of that data linked into one place then becomes very powerful, and actually no extra sensors have to be put into a building. So over to you, Gordon.
Okay, thanks, Peter. Thanks for that. So smart buildings can provide any amount of information, but what does it mean and how can it be used? So I'm going to just show you some examples where data has made a difference, and we're going to go through some of these use cases. First area that I would say, and it's very prevalent at the minute, is reducing of energy costs. As we know at the minute, it's energy costs are going through the roof, and it's imperative that we use that energy as best we can. The data can inform us where the efficiency and deliver financial benefits. We've got a couple of examples of that to share with you. First of all, in an office environment, it was noted the data was able to tell us that the heating was activated early in the morning, way before staff come on site, way before it was necessary for the building to get to its suitable temperature for staff occupancy, and it stayed on way after people left at night. The data was able to highlight this, adjustments were made, and there was no change to the way of the working of the site, just the heating activity was changed, and there was a 10 to 15% saving on that one site. Now, that was one of many buildings owned by one customer, and they were looking to roll that out. So that's a significant saving just on heating alone from the data. From a leisure perspective, there was a leisure centre, and they had various exercise studios. The exercise studios have air conditioning, and for some reason the data was able to tell us that the air conditioning was run on a 24/7 basis when the site was not occupied 24/7, and it was not needed, and a simple adjustment in this instance allowed for a 25% saving in relation to the air conditioning. Again, when you roll that out across a number of sites, it does become sizable. And also just in energy costs as well, from an industrial point of view, there was a factory that they were pulling in the data, and they found, and there was quite a lot of energy usage, and they found that their cooling and heating systems were working against each other, resulting in a massive energy inefficiency, and also mechanical stress on those actual the systems, the heating and cooling systems. Now, that resulted, when they looked at that, in a 5% saving. 5% doesn't sound a lot, but in an industrial background, 5% is significant, and every penny counts nowadays in an industrial background, and the way that the world is at the minute, because it is so expensive to run an industrial site. So that was reducing energy, which is a big area, but that moves us nicely on to proactive maintenance, which the data can identify, assess, and proactively manage risk. It will identify critical building systems that are not working optimally. And we all want, when we've got a system in place, we want to know it's working to its optimum and it's giving what it should do. As mentioned previously, due to the identification of the problem with the cooling and heating working against each other in the industrialist unit, that was identified and that was addressed, and that was a part of sort of maintenance that has helped extend the life cycle of that air handling unit that was being used, and also extends the predicted lifespan. So that was a twofold win in relation to the data that was received there. So it was a reduction in energy, but it was also helpful with regards to maintenance and the lifespan of the machinery. Another area that there's been very good evidence in relation to maintenance was that there was an M&E equipment maintenance aspect, where on a campus accommodation, the provider was working with a university, and this had previously been scheduled maintenance, but they decided to change that, and their key HVAC and their M&E equipment was all changed to on-demand approach for their maintenance. Now, some people might think that's slightly different, strange, but what actually happened was all that key equipment was being monitored, and the data from that key equipment was being monitored, and they were using the manufacturer's data and maintenance as, and that is now completed, where the performance of key equipments, they look at that and they look to see if there's any degradation in that as part of the day-to-day operation. So they're using the data provided by the manufacturers and measuring the data of those systems. The key indicators provided precise timings when work should be undertaken on that. And this had identified a number of areas, and there was a 6-figure per annum saving for that customer across quite a number of sites. So again, a very significant saving from the data there. Next area I'd like to talk about is health and safety. And really, we all want to safeguard occupant well-being of buildings. Massive thing to us all, from insurance point of view, from customers, etc. And in a recent case, there was a potential Legionella risk found when the data was able to tell us that the water storage on site, we're talking about cold water and domestic hot water. The cold water was being stored at above 25 degrees, which can accelerate the growth of Legionella to dangerous levels. So that was a very important piece of data that was received in. But also in the hot water, the domestic hot water in the kitchen area, it was below 49 degrees, and this needs to be over 60 degrees to prevent that the hazard of Legionella. But also from a health and safety point of view, the data will tell us so much in relation to how the building is used, what it's being used as, various rooms being used, how often they're in there, knowing where people are in the building and things like that, because you know when things are turned on, turned off, etc. So there's a massive amount of information there comes out of data, and that moves on nicely into comfort and productivity. And again, you know, using the leisure centre as an example, and it's no surprise that in their gym area that there was quite high levels of CO2, but this was, you know, probably going to cause a problem, and really ventilation needed to be improved and will be improved upon to allow for that customer comfort. Also recently, as you know, we've come out of a pandemic, or hopefully coming out of a pandemic, and there was an office building where the monitoring was being undertaken. It was noted that various meeting rooms where people were going into seemed to be too hot for the, so the comfort level wasn't good, because there was noted a significant drop in temperature periods, and that was caused by people opening windows. The rooms were too warm. So what we need, comfort and productivity go hand in hand. If the customer or the employees are in a comfortable environment, they will work better, etc., etc. So it's really lets us understand how the building works, can help us make decisions on how best to use that building, how best to use those rooms, etc. All this knowledge can be really helpful in relation to future projects, future ways that we want to use our buildings, how we want to use them to work with the buildings. All that is fantastic information. The other thing too is that that's very important nowadays. We all know the issues with regards to employment and recruitment. You know, if we've got a nice building that works well, and that's another edge to that, and it can give us a competitive edge over other customers if your buildings seem to be working really well, etc. Another point that I just want to briefly touch on is prevention of losses. And so you're probably going, how does that work? I don't understand that. Well, I'll give you a couple of examples here. One relates to a comms room in an office. So the data showed that the performance of the air handling unit was reducing in the comms room, and there was a build-up of the humidity within the comms room. There was also a blockage, and if that had not been had gone undetected, actually, there was every chance there was going to be an escape of water with the build-up of the humidity and stuff. Water and, as you know, comms rooms don't really go well together, and so the likelihood was that there was going to be some form of significant damage to the computer and processing units. Now, that alone is bad enough, but think about the business interruption aspect as well to that office, because they will rely on that comms unit, and that's it. So that was a significant issue that was spotted, and the customer in that instance found that really helpful, and was looking to again roll out and make sure that they can get their data monitored in various areas which are high risk as such. Another one, water leak detection. This relates to a fire protection system. So you've got the likes of there was a jockey pump. A customer realized that the jockey pump was working and kicking quite a lot. So they suspected that there was a potential water leak on the supplies feeding the fire protection system. So the jockey pump, it was monitored, and the data came back to show that it was operating about 3 to 4 times per hour for 3 to 5 minutes. So that's quite a lot of water being pumped about. It was a cost issue, but also apart from the cost issue of the water, etc., and the running of the jockey pump, there was the potential impairment issue of the fire protection. So there's a leak somewhere. The water may not have enough water, which is a requirement under sort of fire protection, and that could have resulted in, if the sprinklers were called into action, that they could not maybe have worked in the way they should have. So there's a twofold sort of win there for potential prevention of loss there. Last point, just to go through with you here, is management of risk. Data helps us identify possible failures in building systems before they happen. That's great. That's what we want. But it also encompasses all those points that we've talked about. So management of risk is a very holistic, rounded aspect, and it also can demonstrate behaviours, management behaviours, which is very important. So, for example, there was one instance that we know of that alarms were continually being triggered within a site, but they were not being investigated. What does that tell you about management behaviour? The data will tell us everything. We have to act upon it, and that's good management behaviour to act upon it. Myself as a risk engineer, that's what I'm always looking for, yeah, and the likes. The other thing from a management behaviour and management of risk, your risk may have various areas. There may be some sort of high risk areas on your site, and you may want a bit more information about that. So possibly looking at additional sensors and things like that, so that you're confident that you know what is happening in those areas, whether it's from security, whether it's from just a fire aspect, whatever. There's all these points to take care of. That was a very quick run through some use cases. I'm now going to go on the next site, which I'm going to ask yourselves to help us out with, the next page. So what it is here, this is just a little discussion that I'm hoping that you'll take part in with us, and just put comments into the chat. So the question I'm posing here is, what are the main challenges, barriers and risks to implementation? And what I mean by that is, and I'll give you an example. The buildings are swimming with data. Peter has already told us there how many data points can come in off a site, etc. So it is easy to collect that, but how easy is it to make it useful? I, as a risk engineer, I've gone out on many occasions, and I've sat and spoke to the various guys on site. I've looked at BMS reports, massive amount of data, but I'm not really sure what it's telling me. So what do we need? What do we need? How do we put more around that data so that we understand what it's telling us? What is it challenging us with? So what we're looking for is some sort of provider that will be able to interpret that and give us an understanding of it. So that's the first point I'm saying. So hopefully that's given you some time to think about it, about challenges. So if I just, I've got the chat open. So we've got the first question from Mark of our first point, and it says, need a team dedicated to looking at and understanding the information and interpreting it back for the management to then take action. Pete, you want to have a chat?
Yeah. I just think it's really, if the data is brought into a central point and it's analysed, so the key would be any data coming in is brought in and normalised, and then that via a data service, it wouldn't necessarily need a dedicated team. So looking at a central point of information and then having that as a service into the management team with the sort of rule, you could set up with a rule system in there which will just give you the information you need. So understand that it would seem like a lot of information, but it's key to find a supplier who can supply you the data in the format you need it.
Okay, hope that answered your question, Mark.
Okay, the next one I think is for me as well. Yeah, so the incompatible systems, again, systems, a lot of systems, they don't talk to each other, but with the advent of not just so much IoT but building controls, there are devices there now which can talk across with minimal installation across different devices, and they could bring the data into one place. and not necessarily through the cloud. They can be from locally within the building, so it doesn't necessarily have to go out to the cloud as a load of information and come back in again. So there are definitely solutions for that now.
Yeah, there's quite a few questions coming in. I see there, Ailsa has Collins. It's just lots of older buildings will not always be easily adapted.
So I think that side, I think that's where the IoT information comes in. So the key to that would be to really identify what you want to understand out of the building. Sensors have come down considerably in cost to fit wireless sensors and such like. So older buildings don't need to be taken out of the equation, but it's really understanding what you want to learn from that building and what you can change to improve.
Okay, and Angela Dean, is retrofitting costs and technical difficulties in older buildings? I think you've partially answered that one there.
Yeah, I think the same. Is it? Yeah, it's. I think really is similar. And also point on accurate data at all times. So internet problems. Agreed. There's the consistency of data is very much how it's extracted from the building, what extracts it, but also not all solutions need to go out to the internet, and therefore they store and hold the data in the building, in the area, and then they would then transfer that out to the internet, and it can then be used and sorted and normalized.
Okay. Gary Elliott has mentioned cost and data interpretation. So yes, there is a cost to this, putting various sensors, etc., and the likes, and also looking at trying to interpret that data. But the thing I would suggest to you, Gary, is that there's always that return on investment that you can see. Some of the examples that I have given earlier on there. Yeah. Just looking at the cost of running an operation at all at the minute is extensive, and that will, I do think that will offset that.
Just picking up on Mark's comment. Well, Mark, you from your previous comment, I see where you're coming from. You're saying interpreting with the original and existing equipment. Part of it is you require a hardware solution, so software alone is not going to give you the result. So again, identifying the equipment you want to look at, the sensors that are all best suited for it, and these days there is such a plethora of information and sensors out there and data captures devices. It's really understanding what you want from it. There will be something that will do it, which can then be brought back in to give the information for a software platform to deal with it. So yeah, I agree that software in itself is not a solution. You do need to understand your hardware capabilities. And the data vulnerability, certainly if it's brought in and the way it's collected, and it should be collected, is held locally on site through a secure connection. A device that holds something which is encrypted at in action and in stationary, and then is moved encrypted to a high level of security standards is important, and separated from any network it's collecting data, and certainly should be separated from the main building networks. So really it picks it up and then pushes the data out in a one-way format, so it can't be used to control the data coming out. Is literally a flow out, no flow in.
Okay. And
one from Richard on timeliness of reporting and actions. Well, the reporting from data these days, there's no reason why any data cannot be current within easily within a few seconds of a building. Sensibly, most things that are interpreting data will be 5-minute lag, not much more than that. And it just depends on how the data's been lifted up and how it's been compacted, and also understanding again the data you want, because there's a huge amount of data available, but you really want to get the quality of the data, not the quantity. And if you get the quality, then you're not going to move as much. Therefore, it's a lot quicker to bring the data up. And automated reporting then becomes very simple through the variants of software.
Yeah, and on that, Richard, there's as Peter said, there's data that comes through straight away, but there's also, you can look at trends. You can look at how the building functions at different times of the year, how it functions with regards to occupation and the like. So there's a whole remit of ideas there, and then that can be reported on as well, and through a provider, and given sort of action points and the likes, because that is what's happened with all those use cases that I'd shown there. They've been over a period of time, they've used the data, found it, realised that there may be issues, etc. So that's how that has worked there.
Just to go back, Simon was a very early question that we went past. So just reading back through, Simon. So I think there's a couple of things you're saying about extensive investment in BMS and IoT. You know, there isn't a requirement. If you've already got a BMS system there and it's well managed, you will be able to pick up a lot of data from there without the requirement of, so we say, dedicated pieces of equipment. That if you were sticking with a BMS manufacturer and their own solution, you'll tend to be charged to fit it. And there's sort of, it's an industry, it's not an industry standard, but there are now industry standard solutions out there which will read across different BMSs, bring the data in, and let you get that information. So integrating it's a lot simpler than it used to be. Certainly, I've experienced where I spent weeks on buildings bringing different systems together. These days, it's properly planned with the right equipment. You should be able to bring, you know, a large building together with the data in a very short space of time in less than a day.
Thanks, Peter, for that. I think that's all the questions I see so far. So on that, I think I'll hand over again. I'll move this forward to Louise.
Thanks, Gordon. So yeah, challenges and barriers, lots of them, but still a huge amount of benefit. And I suppose this slide kind of summarises a lot of what we've talked through, actually, particularly around the challenges. But, you know, if you are going to successfully implement IoT, the first place you have to start is agreeing what those objectives are, exactly what Pete was saying when we were discussing the challenges there. So firstly, agree those objectives. What are you looking to achieve? Is it aligned to your organisation's overall goals? Ensure that what you're looking to achieve also aligns with other functional leaders across your organisation, and that you do have that senior support. So once you've then agreed those, your objectives, you then need to develop the IoT use case. And that's again what Gordon and Pete were just talking about. So developing that IoT use case, but then also the value that your IoT pilot will deliver across the organisation. So absolutely, it could be those operational improvements, such as the predictive maintenance, additional security for critical assets or high security areas, or perhaps certain types of buildings that you want to monitor. But once you've determined what your use cases are, it's then important to determine what success looks like for them. And how will you know that that use case has been delivered? So it could be a financial saving and a financial KPI that's generated around maybe the energy utilisation or fuel or even labour. And those areas, those business cases typically have an expedited return on investment. But success for you could also be 24/7 monitoring of a critical asset with 0% unplanned downtime. So that success measure and your use cases need to be tailored to what you're looking to achieve. So once those objectives and use cases have been identified, you then need to validate with the various stakeholders and business partners across your organisation. So IoT projects will typically cross over several business functions. They're not projects that you can implement in silos. So it's a crucial step to ensure that your approach is validated and agreed with all of these key stakeholders. And then once you've got that overall agreement and support, you can start to map out what your IoT vision and roadmap is, clearly articulating what your key milestones are as you move through implementation and launching your pilot, identifying the correct IoT provider, exactly what we were talking about there in some of the challenges, that aligns to what your goals are is a key part to this step. What other services can they also provide you, and how can the technology help with some of those challenges identified? And what other skills do you need within your organisation? Do you require additional data analysts, or will that provider support? And there's also the time when you should be identifying what other associated risks and then the appropriate controls. So as you're getting to launching, it's time to check back in with those internal stakeholders and ensure that your internal support remains in place and that there is complete agreement on your controls and the overall deployment. And then with the pilot complete, you can then review those initial objectives and understand if they've all been delivered. So if you do need to make amendments, then that's where, again, you need to update the vision and roadmap and then validate it with your key stakeholders. It's really important to keep the stakeholders in the loop at all times, because as I said, this does cross functions and everyone needs to work together to deliver the success. So you're all ready then to implement your initiative, and I'm sure when you do it, it will be very successful. So then you will then move to the final part, which is maintain, monitor and review. So again, ensure your objectives are continuing to be delivered. You've got periodic reviews are in place with your IoT provider and relevant functional leaders. And then as you're going through the process and as it's being delivered, you will develop further learnings and there will be additional efficiencies. And the technology will evolve. Technology in this space is changing rapidly, and some of the controls as well that you've implemented could fail. So as and when this happens, you need to move to the start of the cycle and restart the process again. So having that having that structured process with clear objectives, stakeholder agreement and support with clear measures of success defined will absolutely deliver a successful implementation. So I think we move on to just summarise. So yeah, to just summarise the key points, IoT is here to stay. Benefits and opportunities are only going to increase from improving energy utilisation, operational efficiencies and delivering proactive risk management. Implementation should be planned and structured to ensure success. IoT might sound like the solution for everything, but it needs to be the solution to something specific to deliver the value that you need. Different skill sets will undoubtedly be required. How will your future workforce evolve as you start to implement additional IoT and then potentially link this with additional IT solutions such as AI? And yet challenges absolutely do exist, as they do with most business initiatives, but with the right skills and approach, these can be overcome. And Zurich are here to support you. So not only do we have an IoT proposition that is independent of any insurance arrangement, we also have the expertise to support you on your IoT journey.